In this section, we're going to be finding absolute maximum and minimum values of functions, or also called absolute extrema, which means that they are the highest or lowest points over a function's entire domain. And in these examples, we're specifically going to be looking at finding absolute extrema over closed intervals. So for example, in this first problem, we're looking over the closed interval 0 to 5. So we have endpoints to our interval. And what the extreme value theorem tells us is that when we have a continuous function defined over a closed interval, we must have an absolute maximum value and an absolute minimum value. So to find the absolute maximum and absolute minimum values, we can use the maximum minimum principle 1. So when using the maximum minimum principle 1, the first step is to find the first derivative. So we're going to find f prime of x. So taking the derivative of this function, we have 3x squared minus 6x as our derivative. Our next step is to find critical values in the interval 0 to 5. So to find critical values, we look at where the first derivative is equal to 0 and also where the first derivative does not exist. Since the derivative is a polynomial function, it is defined for all real numbers in our closed interval. So we're just going to focus on where the derivative is equal to 0. So setting 3x squared minus 6x equal to 0, we can factor out a 3x out of both terms. So then we're left with an x minus 2 equal to 0. Setting each factor to 0, we get x equal to 0, and then an x minus 2 equal to 0, so we get x equal 2. So our two critical values then are x equals 0 and x equal 2. So now we can create a list of all the critical values and also the endpoints of our closed interval. So our list then is going to look like we have a 0, a 2, and a 5. 0 and 2 are endpoints for our closed interval, so they must be included in our list. And then any critical values. So that's where the 2 comes from. So now we're going to plug every value in our list into our original function and get the function values for each of these values in our list. So we can begin by plugging 0 into our function. So we have 0 cubed minus 3 times 0 squared. So we end up getting a 0 as our function value. Now if we plug 2 into our function, we have 2 cubed minus 3 times 2 squared, which is going to give us a negative 4. Now if we plug 5 into our function, so we have 5 cubed minus 3 times 5 squared, which is 125 minus a 75 to give us a function value of 50. Now what we do is we compare these function values. So here we have 3 function values. The largest one is going to give us our absolute maximum, and then the smallest one is going to be our absolute minimum. So since the smallest function value out of these 3 is a negative 4, that is our absolute minimum over our closed interval. So our absolute minimum is negative 4, and that occurs at x equal 2. And then our largest function value out of these 3 is 50. So that is our absolute maximum is 50, and it occurs at x equal 5. We can verify our results by using our graphing calculator. I'm going to hit y equals and then type our function in our y1. So I'm going to type in x cubed minus 3x squared. And then before I hit graph, I'm going to check my viewing windows. Now since we're looking on the closed interval 0 to 5, I've changed my x-min to be 0 and my x-max to be 5 so that we're viewing the function on that closed interval. And then for our y-max, I've set that at 60 because we found that our absolute maximum value was 50. So I chose 60 to be sure to capture that absolute maximum value. Now if I hit graph, there is our function on the closed interval 0 to 5. Next, what I'm going to do is I'm going to calculate the function values at x equal 2 and x equal 5. We said that our absolute minimum occurred at x equal 2. So I'm going to hit second and then calc. And I'm going to choose the first option, value, and hit enter. Now I'm going to enter 2 for x. And when I hit enter, there we see we get a function value of -4. And looking at that graph, that does indeed look like the absolute minimum value for the function over the interval 0 to 5. Now I'm going to hit second calc again and hit enter, so we calculate another value. And this time I'm going to enter 5 for x and hit enter. Now we get a function value of 50. So notice there is our absolute maximum over the interval 0 to 5. It does in fact look like that endpoint there at 5 is the absolute maximum value. Let's look at another example where we want to find the absolute maximum and minimum values of the function x to the fourth minus 8x squared plus 3 over the closed interval -3 to +3. So our first step is to take the derivative. So f prime of x is going to be 4x cubed minus 16x. And then the next step is to find our critical values. Since we're looking at a polynomial function defined for all x values, then our critical values are going to occur then when the first derivative is equal to 0. So we're going to set this equal to 0, 4x cubed minus 16x equal to 0. So we can factor this. We can factor out of 4 and an x. So then we're left with an x squared minus 4 equal to 0. Factor the x squared minus 4, so we're looking at 4x times an x minus 2, x plus 2, factoring that difference of two perfect squares, equal to 0. Now setting each factor to 0, we get x equal to 0. Setting the next factor to 0 will give us an x equal to 2. And then the last factor there will give us an x equal to a -2. So those are our three critical values. So next we create our list. Our list is going to be of our endpoints. So in this case our endpoints here are a -3 and a +3. So those are going to be two values in our list combined with our critical values. So we have a total of 5 values that's going to make up our list. So we have a -3, a -2, a 0, 2, and 3. And again, this list comes from listing all of our critical values combined with our endpoints. And just to remind you, what we're using here to solve this problem is the maximum minimum principle 1. We're using that because we're working on a closed interval. So now our next step is to take these 5 values in our list and plug them into our original function. So we're going to begin by taking f of a -3. When we plug a -3 into our function, we have a -3 to the fourth minus 8 times a -3 squared plus 3. And when we simplify that, we get 12. So next we're going to plug in -2 into our function. So we have a -2 to the fourth minus 8 times a -2 squared plus 3, which when we simplify we get a -13. Next we're going to plug a 0 into our function. So we have 0 to the fourth minus 8 times 0 squared plus 3, which comes out to give us a 3 as our function value. Next we're going to plug 2 into our function. So we have 2 to the fourth minus 8 times 2 squared plus 3, which when we simplify we end up getting a -13. And then last, plugging a 3 into our function, we have 3 to the fourth minus 8 times 3 squared plus 3, which comes out to be 12. So next we compare these function values. whichever one is the largest is our absolute max, and then the smallest is our absolute minimum. So when we compare this, it looks like our largest is 12, and then our absolute min is a negative 13. So our absolute max is 12, and it occurs at two different x values, at negative 3 and 3, and then our absolute minimum is a negative 13, which occurs at two x values, negative 2 and positive 2.